So, as we were talking in the last video, right before the phone rang that we were using to actually record this or film this, we were talking about there were different types of piping material. So what I did is I took that time to go ahead and change the book over here. And as you can see, again, we are still on table 402.4. It's just that we went to chart number 26 there in parentheses. This particular material we're going to talk about on this slide is Schedule 40 metallic pipe. You may see me or hear me speak of it as black iron pipe because in the field, when you get ready to do this kind of work, you're not going to go in and ask for Schedule 40 metallic pipe. You're going to go in and ask for black iron pipe. Just know that that's one and the same. Black iron pipe and Schedule 40 metallic pipe are the same, one and the same. Okay? Now, I went ahead, since you've seen the other chart, I went ahead, there's also a chart for metallic pipe with copper, metallic pipe with natural gas, but this one, we're actually going to use the metallic pipe or black iron pipe chart. And I went ahead and went to propane, so you can see a little difference up here because the inlet pressures are a little bit different and the pressure drop is a little bit different. So let's talk about propane, but again, all the materials are listed for each gas, whether it be natural gas or propane. So let's look at this here. As we stated earlier, we're talking about undiluted propane. Inlet pressure on propane will always be on residential 11 inches of water column. Most any appliance that we deal with is going to need 11 inches of water column gas pressure at each gas valve. So we are using the correct chart here because we are using 11 inches of water column. Again, they list many other ones. I'm not sure why they have those in there. There may be certain applications where you would use that. But again, for everything that you're going to do in residential, it will be 11 inches of water column. That would be the inlet pressure. Now here, pressure drop, we don't want anything more than 0.5. And we would go lower if we could, but this is the lowest one in any of the charts for undiluted propane. So we're going to use this chart because it's undiluted propane, 11 inches of water column, and the lowest pressure drop, which is 0.5 inches of water column in this particular chart. Again, specific gravity, as I mentioned earlier, propane is 1.5. It has listed here 1.50, 1.5, 1.50, the same, one and the same thing. So the specific gravity, as you see this, as we talked about earlier, you will notice that it is heavier than air. Again, air is 1, so this is much heavier than air, and again, that's what makes propane a little bit more dangerous as far as if you have a leak or an issue of that nature, because it can stack up in a room. Okay? Now, it's kind of still the same. Over here down the left-hand side column is your feet of pipe. So you need to figure out how long your pipe is. And once you do that, you will find that over in the left-hand column. Excuse me just a moment. Okay, sorry about that. I had to go next door. We have a classroom on the other side of us. And I couldn't even hear myself think, so we had to get them to quiet down just a little bit for us so we could carry on. But again, as you can see, down the left-hand side of the pipe, down the left-hand side of the chart is your length of pipe. So you got to figure out how long that your pipe that you're sizing is. Once you figure out how long that pipe is, you would go down the left-hand side of the chart. Then you need to figure out how many BTUs that your appliance is going to use or need. And then you would go up. After you go over from the length of pipe, you would go over to the BTUs that you need, and then go up, and that will tell you the size pipe that you need. So let's just go ahead and look at one here real quick. So if I had, in metallic pipe, if I had a 10-foot section, and I had an appliance that needed 300,000 BTUs, I would go to the first one. As you can see here, it's 291. So that would not be enough. Most would say, well, that's close enough. 291,000 is pretty close to 300,000. But again, you never want to undersize your gas pipe. If anything, you need to oversize it slightly. Okay? So again, we have 10 foot of pipe, we need 300,000 BTUs, so we're actually going to have to go over to here. Now, unfortunately, you see that's nearly triple what we need, but again, it is better to oversize because we're going to put a gas regulator at the appliance. So we have to go over to 608,000 BTUs to get the size pipe that we need for 300,000. Then you would go straight up, and that would tell you the size gas line that you need. Again, right here, this is 3/4. Now, unlike copper, we don't have two different ones. Black iron pipe is a standard size, which is nominal size throughout the United States. So that's how you would read this chart. Let's take one more case just to make sure that you understand what it is that we're talking about. So let's say we had a pipe that is 40 foot long. So we go down the left-hand column, find that we're 40 foot, and let's say that we had a gas appliance that needs 100,000 BTUs. So that particular line at 40 feet, we need 100,000 BTUs. Right here in the chart is 137,000, so that is enough to carry the amount of gas or the volume. So we go up, and you would see that we need a gas line that is a 1/2 inch in size. And that is how you read these charts. That is all for now. I'm going to go ahead next and draw a house out and just draw some gas lines in there to kind of help you read those as I assign those. But this is it as far as the charts. If you have any questions, you can email me or post a question on Blackboard, and I will be glad to answer you back and help you through this. All right, so now we're going to move on to an actual residence, and we're going to go ahead while you can see this. I will be sending you one, so not this exact one, but I will be sending you one by PowerPoint. I will link it up to Blackboard where you can go on and look at this. I will already have everything drawn out. Down here in this area, instead of what you see here, I will have the gas, what type of gas that you're working with, the pressure drop, and the supply pressure to the appliance from the gas valve. So I'll have this all listed down here for you to make that easier. Right now, we just want to give you a general idea of how to take a house and take each gas line and then use the chart to properly size your gas line. So let me go ahead and draw a gas line in here. Now, hopefully when you get into the field, your gas line that you install will not be that crooked. I'm not an artist, so we're going to do the best that we can do. Hopefully it will be straight. That should be straight. Unfortunately, it's not. So what we need to know first is we need to know where the gas meter is. So let's go ahead and draw some box on this end of the house, and this we will list as our gas meter. Okay? So coming from the meter, the black line that I've drawn across there would be the gas line that you would size and install. So this particular line here, and I'm going to try to draw an arrow up and list this. This is what we would call the main gas line. I'm trying to draw it up here out of the picture. As you can see, my handwriting is not that great either, but trying to draw it up out of the picture because we're going to draw some numbers inside that picture, and we didn't want to have a mess in there and make it hard for you to read. So the other thing that you need to know, as we were talking about the charts, is your total BTUs that you need from the gas meter to each of appliance. So what we need to do now is we need to draw in some drops. So I'm going to go ahead and change my pen color so you can see the difference. Let's make it red. So let's put a couple of drops in here. And all a drop is a line that comes off of the main trunk line, and it goes from the main trunk line, carrying the gas to all appliances, to carry the gas to one particular appliance. So again, in black is your main gas line, and the red is your drops to each appliance. So let's go ahead now. We need to know how many BTUs that we've got to carry to each one. So let's go ahead and list them here. This one is going to be 40,000 BTUs. And in most cases, in most residential homes, what you will find is that when you have something around 40 or 50,000 BTUs, more than likely, again, it is going to be your gas hot water heater. So in this particular one, we've got to carry 40,000 to a water heater. Now, when you get out on the job site, you actually have to go to the manufacturer or go to the plumber or whoever's putting it in to figure out what size hot water heater that they're going to install in the house. Because you're out there before the house is done, if you're doing new construction, in this case it would be, and you're putting in a gas line, you would need to know the BTU output of every appliance that's in the house. So we went to the plumber said it's 40,000 BTUs, so we've got that listed. Now, the other appliance that we have in this house is going to be a gas furnace. So most gas furnaces are going to be 60,000 BTUs or above. This is a pretty good sized house, so let's make it 80,000 BTUs. So to figure that out, you would need to go to the HVAC guy, and we're in luck. We are the HVAC guy. We know what size furnace is going in there, and again, we put in an 80,000 BTU furnace. So before you start this process, before you even go to your charts, you need to know this information. The other thing that you need to know is you need to know the distance that the pipe is. So for example, we would need to know what the distance is from the gas meter to the first drop, from the first drop to the second drop, and then from that drop to the end. So actually we don't need to run a gas line this long. I've drawn it this long, so we're going to go ahead and leave it that way. But we really should have ended right here because there's no appliances out here at the end. But we're just using this for just to show you how to measure it up. So again, we should have ended the gas line in all reality right here. Let's use it how it is. The other thing is we know how long our main gas line is because it's the same length of the house. So we know that this main gas trunk is 50 feet. You need to know how long the overall footage is of the main trunk as well as you do the length of each drop. So let's go ahead and list that out there. So the main gas line is 50 feet long. Well, I guess I should change my ink. Scribble that out since I don't have an eraser. Main line. And it is 50 feet. Okay? The other thing that we need to know, again, is how long each gas drop is. So we know that the house, just by looking at this, we can kind of get a pretty close guesstimate. We know that the house is 30 foot deep. So each line is no more than half of the depth of the house. So we know that we're at 15 feet or under. So let's go ahead and call this about 12 feet for this line and about 12 feet for that line. Let's go ahead and list that out there. Again, it's something you will need to be in the field and measure yourself. So we're going to say, again, that is approximately 12 feet. That is approximately 12 feet. So now, the next thing that we need to know is we know the overall length of our main gas line, but we need to know what the length is from here to here, then from here to here, and from here to here. So to do that, we're just going to look at it and kind of get a close guesstimate. So the house is 50 feet. We need to divide that into thirds. 1, 2, 3. So we divide that into thirds. Each gas line is going to be approximately about, let's go with 17 feet. So we've got 17 feet here, 17 feet here, and 17 feet here. So now we have all the information that we need to start this calculation to size our gas lines. So what I'm going to do, just to make this easier, is I go ahead and add up the total amount of BTUs in this house. So total amount of BTUs, it would be the 40,000 right here plus the 80,000 right here. So to add those together, quick math, our main gas trunk starting at the gas meter will have to be sized for 120,000 BTUs. Now again, that tells me how much gas will need to be in this first particular line, because this line has to be big enough to carry the gas for this appliance and for this appliance. The next section now, what we will do is, after we figured out that we need 120,000 for this section, now we go ahead and go to this drop. This section right here only needs enough gas to carry this one here, because we've already took the gas to this appliance. So we don't need to carry that in this pipe because it's already gone to the appliance. So now what we do is we subtract the 40,000 from the 120,000, and that should give us 80,000, and it does. So we need 80,000 BTUs for this section of pipe. So when you size it, you need to look at your chart. You're going to look at 17 feet, and that 17 feet needs to carry 80,000 BTUs. Back up at the first one, this is 17 feet. You would go to your chart, find 17 feet. This has to carry enough gas for this appliance and this appliance. Again, add those two together. So you need to find a pipe size that would carry 120,000 BTUs, the total length of your pipe. Now, in the end, again, I didn't put an appliance out here, so in reality, all that does is help us get our total length. So that's how you would size a house, and that's how you would size a gas line for each appliance, including the main gas line down the center. Now for the drops, real fast, they're very easy. All you do is you go and you find whatever type material you've got. Again, the gas that you're using, 12 feet. We find 12 feet, and it carries 40,000 BTUs. Then you go up, and wherever that intersects, that's the size gas line that you would use for that particular appliance. Now, real fast, before we end this, you can have two different types of materials on one job. I will send you an exercise here over the next few weeks that will have just that. Let me give you a perfect example. So if we're running this under the house, we might use metallic pipe or black iron for our main gas trunk. And the reason why is, this pipe is the largest pipe that goes under a house in most cases, because it's got to be big enough to carry the gas for all appliances. Copper is very, very expensive. And as you get up in size, especially 7/8, inch and eighth, and go up in size, it's very, 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 very expensive. So what you find in most homes is you'll find a gas line, the main gas trunk will be metallic pipe, and then the drops may be metallic pipe, but they also may be copper. So in this case, because you're going to each appliance and you don't need as many BTUs as you do here, each drop in a lot of cases will be copper. So you would need to use the charts for the appropriate gas material as far as copper or black iron, and then the appropriate chart, whether it's natural gas or propane. So make sure that you don't confuse those as you do these exercises. So again, you could use more than one type of material. Black iron pipe, in this case, we would have black iron pipe mixed with copper. You could also have all of the same, and I will list that on each exercise so it won't confuse you. That is it.